Hey there, I'm Christopher Sandoval. I'm a developer relations advocate here at FlowFuse. And today we're going to look at how we leverage Docker to rapidly deploy our FlowFuse instances in preparation for Hannover Messe. So let's dive right in. Why Docker? So when I started this project, I had a few options for how I could deploy FlowFuse onto our server. Because we wanted to deploy both FlowFuse as well as a handful of other associated services, I decided on Docker. But there's actually a few more reasons why Docker is the right technology for this particular application. Firstly, I want to make sure that our services and our instances were isolatable, but not isolated by default. Because we have so many instances that we're setting up, we might run into traffic collisions or port configuration issues. And because of this, I wanted a technology that gave me more significant network control. Now we can get away with doing something like a managed switch. But as you'll see in a minute, we have a few other arguments that make Docker the right choice. By setting my instances up on Docker, I can use the built-in network feature. I can segment networks, I can enable and disable them at will, I can even change port mapping on the fly. And that generally gives me way stronger control over what's actually happening between our instances and our servers. Another huge reason I went with Docker is that it's really easy to spin up a lot of services all at once. Now, because our services and our instances are individually using a low amount of resources, I did consider just spinning them up as individual isolated systems. I also considered building the FlowFuse instances all as individual flows on a single instance, and then having the services actually connected to their own individual ports. But the problem here isn't the typical operation. If each of these systems and services are only using a little bit of resources when they're running normally, that's fine. The problem is when they're running abnormally. What happens when we have a massive spike in requests for database information? What happens when we're doing a lot of read and writes between our ERP and our MES? For that reason, it makes sense to isolate the services and the instances and give them adequate resourcing. By doing it this way, we can make sure that no one service dominates any of the other services and that they all get the processing and the RAM cycles that they need in order to do their functionality. Spinning this all up on Docker also makes troubleshooting really easy. Because we're spinning up everything on Docker, we can make use of their built-in tools for a lot of our troubleshooting. Instead of trying to chase down where we set a port configuration or where a network has been enabled or disabled, we can just use Docker Network Inspect. If we're having a problem with something like a service, we can look at what that problem is, identify the root cause, do a compose down, fix it, and then do a compose up. We don't have to remove database files or remove latent installation configuration pathways. We just simply compose down, rebuild, and compose up. In essence, this gives us a ton of extensibility, a ton of scalability, and prevents us from putting all of our digital eggs in our proverbial basket. Deploying on Docker. So how do we actually deploy these instances? Well, it's actually pretty easy. While every build process is going to be a little bit different, this is probably the easiest way to get going, although it does come with a few caveats which we'll discuss in a moment. So to get started, the first thing you want to do is log into your FlowFuse user area. Now you're probably familiar with the flow for creating hosted instances. You click the button, you assign it some variables like what application it belongs to and its name, and then you spin it up. Now this process is a bit more involved for Docker deployment, but it's actually pretty straightforward if you're used to following the prompts on the FlowFuse site. So firstly, navigate to your home view and click on the Add Instance button in the Remote Instances pane. You're going to assign a name and a type to the instance you'll be creating. For the type, I like to use a descriptive name that gives some sort of insight as to the nature of the remote application. Once this is done, you'll be shown a window for the device agent configuration. Click at the top where it says Install via NPM and look near the bottom of this window. Now I've blurred part of this image out for security reasons, but in this section you'll see your device configuration. This is going to be how you actually create your FlowFuse instance on your server, so leave this window up or copy it somewhere for safekeeping because we're going to use it in the next step. Next, go to wherever you want your instance to be deployed. In my case, FFserve1 is a remote server that I access via an open source tool called RustDesk. This allows me to manage all of our servers and devices on the same singular end device. Now that I'm connected to the server, you can see that we already have Docker running, as well as a few instances and some associated services. Now what we want to do here is create a new device. To do that, we're going to need two specific files. You can create these within the GUI if you like, but I'm going to work in the terminal. Firstly, make sure that you have a folder for these files. In this case, I have a folder called FlowFuse Local Test Bench. So I'll open the terminal window, change my directory to the working folder, and use the touch command to create device.yaml and docker compose.yaml. Now these two files are going to serve important functions. Firstly, device.yaml will contain our configuration info that we got from the remote instance setup process earlier. The docker compose.yaml file will allow us to set up this instance and connect it to a network. But more importantly, if we want to scale the stack in the future to have more than one instance running, we can simply add it to the docker compose file. I'll post the Docker Compose file in GitHub so you can see exactly what this should look like. With both of these files in place, we'll use the terminal, first making sure that we're in the correct directory, and issue the command docker compose up. This will build our instance. Now, if you want to watch the entire build process, you can use that command and hit the D key to detach the process from the terminal window after the lines are done updating. This will allow you to close it down without terminating the process itself. If you don't care about the build process at all and just want to issue the command to build your instance, then add the D flag to the command. It should look like this: docker compose up D. Now we can see that we have our remote server ready to go. A brief project overview. Now with this in place, let's take a moment and look at what our project looks like today. On FF Server 1, we have a mix of instances and services. We're using Cloudflare on both FFserve1 and FFserve2 to route any external traffic to our internal IPs. For security reasons, we're using this relatively sparingly, and each URL that we issue with the Cloudflare command is protected by the Cloudflare login flow. Now from here, we have all of our FlowFuse instances collected under a single stack. We're using these instances to both bridge between FlowFuse devices from the local to the cloud, as well as between a sorted database, ERP, MES, and other end-user solutions. Now in FFserve2, we have less instances, but they're actually more power hungry. In addition to our Cloudflare instance, we have a service running called Computer Vision. Now we'll get into what this particular service is in another video, but suffice it to say, we're doing some pretty cool things with Computer Vision in this particular demo. We have two remote instances here that allow us to connect to the FlowFuse platform. Now these instances are managing an incredible amount of data, and I'll talk about one of them, the AI Bridge, in our next video when we talk about our Ollama local model deployment. I'll see you at Hannover. This has been an incredibly fun project. We're obviously doing a lot of interesting things that we just didn't have time to do on our demo at Prove It. I'm really excited for you to see what the end of the road to Hannover looks like when we get our server deployed to Hannover, Germany. For now though, we hope you enjoyed this video. If you did, please consider giving it a like, comment, or subscribe. Check out the links in the description below to find a link to our GitHub with all the files that I just talked about, as well as a link to a playlist for the videos in this series, The Road to Hannover 2026. And if this piqued your interest in FlowFuse, head on over to flowfuse.com to start your free 14-day trial. This has been Christopher Sandwell. Thanks for watching, and I'll see you next time.